This conference will now be recorded.
You can see my screen.
Not yet.
What is cross compilation? Can you see here? Cross compilation is act of compiling code for one computer system, often known as target, on a different system. That's called a host. So here your host is your PC and you're compiling your application for another board. So that's why it is called cross compilation. It's a very useful technique. For instance, when the target system is too small to the host, the compiler and all the relevant files. So now the embedded systems are always, that it is meant for specific applications. It's a small only. Maximum it is small only. So for writing the applications, you cannot go and make a host. So there won't be any UI tools available to compile in your embedded devices. That's why we are choosing a host PC, that your computer, and you are compiling your application in your host PC for that target board. That is called cross compilation. To cross-compile is to build one platform a binary that will run on another platform. When speaking of cross-compilation, it is important to distinguish between build platform on which compilation is performed and the host platform on which the result is executable or expected to run. So it's all about again the same thing. You are doing a application for a target board. That is the overall thing of cross compilation. For doing cross compilation, what we need? Toolchain. How do you compile a normal C program? Is gcc filename.c, right? So a toolchain is a set of tools that compile the source code into executables, right? So gcc is a toolchain for us. Now our code, our normal computer code is compiled by using gcc. I compiled by gcc compiler that that can run on your target device and includes a compiler, linker, and runtime libraries. Initially, you need one to build all these three elements on embedded Linux systems: the bootloader, the kernel, and the root file system. So first you have to build, when we have seen in the first class, first we have to build a image, right? Images for your target board. They will give the preloaded images, but you want to customize them and you want to load the customized images into that board. So what are the images you need to make ready is, first one is, as you know already, bootloader, U-boot, second one is kernel, and third one is root file system. I've told you how to make partitions in the SD card, how to compile the U-boot, how to load it, what are the commands. To check in the documents, exact follow the same, that is enough. So now for compiling all these bootloaders, kernels and root file systems, what I need to have? Toolchain. So first and foremost thing for board bring up activity is to build a toolchain. How do I build a toolchain? Yesterday I shown you in the document. You have to go to the buildroot.org folder in the directory and just check for your board support in configs directory, give make command and give make menu config and then run it. After you will get the files in output directory, all the related files. So all the compiler, linker, so you know the stages of compilation, right? So all the stages of compilation we need a compiler, linker, interpreter. So all this will be now ready for your target board. Now you can compile your application for your target board. So now this is how it looks like after compilation of your tool chain. What are the tools you will get as an output is, this is how it looks like. You have binaries, you have libraries, you have some share any share files, and you have binaries, means you have to see what are the binaries. These are the binaries. So like GCC, you have to use ARM, FSL, Linux, GNU, EABI, GCC. So how to compile my code now means write a program vm hello.c, and this program I'm writing for my embedded device, not for the PC. Okay, now printf, same, the code will be same, code is no change, but compilation is where the change exists. Now I have this application. Usually what I will do, gcc hello.c, I will compile and I will run this binary. I will get hello. And if I check file as a command to check it is compiled for which kind of architecture, it is telling it is x86-64 architecture, dynamically linked interpreter. So all the information you can get it by using file command. Now that what I will do, I will compile the same code with using ARM FSL GCC hello.c. We need to export the path, something is missing here. So now instead of GCC you have to compile with ARM and GCC. Okay, then I will do no such file or directory. I think I have to export the path. I mean, I have to move all this toolchain into corresponding directories that will be present in installation code. Now what I did is I have compiled the toolchain for my ARM architecture. After compilation, I'll be getting this directory, and in this directory, I have all the binaries which are required for my compilation. That is GCC, G++, and object copy, object dump. What is the use of object dump? If you want to open a binary file, .o file, it's not possible with VIM. So that's the other option to see the human readable format of a relocatable file or object file. You have to use object dump. That's all. So you have to compile like this. Instead of GCC, you have to use ARM and GCC. And if you give the file command and check the output, then it will tell you it is compiled for ARM architecture. Clear? Clear about toolchain? Clear?
Yes.
So now we see how to compile U-boot, how to compile kernel, how to compile root file system, which are the images required to boot your target board. Means the first images required. First see U-boot. What is U-boot? Bootloader. What is the use of bootloader? So why we require a bootloader means, okay, we'll see that. What is a bootloader? Bootloader is actually a small program. U-boot is one of the flavor of the bootloader. What is this program will do to the bootloader is, as you can see, this is 3-part series of complete procedure to cross compile. So now what is the requirements as the same thing? You need a ASCII card, you need a host PC, everything they are also telling topics to be discussed. What is a bootloader? So you can see what is actually bootloader. And now in this short, this is a piece of software which is executed as soon as you turn on your computer or hardware device. The hardware device can be anything from your mobile phones, routers, micro ovens, anything. After all, everything has to beginning, right? The reason I said there are so many ways to answer this question is because use of this device is different. We need to choose the bootloader carefully, which initializes the device. Okay, that's all. Okay. In embedded systems, the bootloader is a piece of software whose main purpose is to load the kernel and hand over the control to it. As I told you, when I switch on my power button, so there is some BIOS operation going on, basic input output operation. The BIOS operation is a kind of pre-programmed code. It's given by the vendors itself, and it contains an instruction, jump instruction to some address location. So after going to that address location is where your U-boot resides. What is the use of this U-boot is to actually the kernel is a complex program. We are launching a complex program with the help of a simple program called bootloader. Why? Because the RAM, initially in SOC, there will be two kinds of RAM, static RAM and dynamic RAM. So before starting initialization, your dynamic RAM will not be initialized at that moment when you press the button. Static RAMs are very less in size. Say for example, it will be only 1 GB. Dynamic RAMs are now 4 GB, 8 GB. But loading the executable directly into the static RAM it is not a good idea. Why? Because it is less in size, and why it is less in size means it is costly compared to DD-RAM. The static RAMs are costly. So for initial loading process, we are putting a static RAM as a part of SOC. So that's why initially we are loading a small program into the static RAM. Why? Because dynamic RAM is not in picture now. It is not, it will initialize now at this stage. So after loading your U-boot into the static RAM, then the job of the U-boot is to load a complex program, and the complex program will load as a kernel into the dynamic RAM. At this point, the U-boot will initialize dynamic RAM also. That is the main reason we are using bootloader. You got that? Why we are going for U-boot? You got the point? Hello? Hello, am I audible? Hello? Hello?
Yeah, you're audible.
Yeah, you got that the difference why we require a small program to launch a big program like kernel. What is the need is static RAM and dynamic RAM concept. You understand that? SOC means system on chip. If you buy any board from the vendor, they will give some basic things on the system itself, like processor, I2C controllers, and lot of things they will integrate in the same board and they will give it to you. So in that board, you'll have static RAM also. That is less in size and it is costly. That's why they keep less in size. More size means you have to pay more. So that's why they mostly will keep in very less in size. So everything has to load into RAM for getting CPU time, right? So for that, you have to load your U-boot into the static RAM. After clicking on the power button, the BIOS will execute, and the BIOS will execute the bootloader, and the bootloader will be loading into the static RAM first, and then the bootloader will load from the kernel, and the kernel will load the root file system. This is how the flow will be. Now see how to compile this U-boot. how to compile the U-boot. So same procedure like what we did yesterday. Yesterday we have compiled a toolchain, right? Again you have to go to one source code. Boot sequence of an ARM board is like it is like how is the boot sequence? Every embedded board is first boot ROM code, and from there it will go to the MLO. It is first stage bootloader, second stage uboot.bin, and then kernel. So it is there is no guarantee that you need a first stage bootloader. You can have only one stage bootloader like uboot. First boot ROM code, next uboot, and then kernel, and then rootfs. This is the boot sequence. Now what you have to do, you have to make the uboot.bin ready. So for that, go to this FTP, means file transfer protocol. Go to this particular website and download the uboot source code, and then the build root. Yesterday you compiled a build root, right? Build root by using build.org. You have downloaded one tar file in the downloads directory. Okay, let me show that. So this is the build root we downloaded yesterday. And what is the first step you have to go check is configs directory. Go and check in the configs directory about your support of your board, whether your board has support or not in the configs directory. So here lots of board supports are there, and then what you have to give, make menu config and make whatever the board you want, make. It will start compiling and it will generate the output. So it will take time. So it will generate the output in the output directory. You can see the output directory. Here you can get the, see these are all the binaries and libraries for my target board. So whichever board I have selected there, it will generate that board related files. Okay, now your build root is ready. I mean your tool chain is ready. Consider you have ready with your tool chain. And what you have to do, you have to compile your uboot. First download that one. Check the board support or BeagleBoard Blackin configs file. How the uboot looks like, I will tell you. I will show you. Uboot source code. This is my uboot source code for my ARM board, the board which I have worked on. This is the uboot source code. It looks like this. What you have to do, you have to cross compile this uboot file, uboot source code for your target board. How do I do that? See now, arc equal to ARM, architecture equal to ARM, cross compile equal to, I am giving the path. You can see before I show you ARM, FSL, Linux, GNU, AE, BI, GCC, right? So I am installing this tool chain in that particular path. You can see this path. So I'm writing the path for this macro and I'm specifying for which architecture I'm compiling, and now giving this make mx6sl evk config. So this is my board. i.mx6 Sololite is my board. So I am compiling for my target board. Make I am giving, and what is the architecture I am giving, and cross compilation path I am giving. And then after hitting the make button, make config and make. That's all. You will get a uboot.bin file. I'm just copying. You will get the final output like this .bin file. I'm just changing the name of uboot.bin to proper name according to my wish. So it is created in 1520 build number. What is the version of it? So I am writing. Any confusion? This is how we have to compile it. Very simple. You can do. Just download the uboot source code. Whichever is the whichever is the board file. So here you have to change your board file related config. If you are using Beagle board, you have to go and check in configs directory what is the correct for your, there is a directory. You have to check in the configs directory for your board support and then compile like this, and you will get the final uboot.bin file. How to load it I have shown in the first class, right? You have the load command, load command, and you have to partition your SD card, load the image in that. So this is the file, uboot.bin file. This is the image file. Similarly, kernel also same. Here, download Linux kernel from kernel.org. Check the board support for Beagle board in this directory. Make arc equal to ARM. So I am using for OMAP. OMAP is another kind of board. So if you want for OMAP is one kind of Beagle board version only. So this is also ARM architecture, Beagle board also. So now give this command, cross compile, and after you will get two binaries. One is image file. So how does the kernel image look like? Let me show you. This is my kernel source code, and the kernel image look like. Usually it will get, we will get in, sorry, we'll get in the name of JUD image. What I am doing here, if you see in the script file, 1 second. Yeah, this is make menu config architecture equal to ARM, cross compile equal to give the path of the toolchain, and then make. And here I am making it as an image by using mkimage. Mkimage is one kind of tool. So you will get a kernel image in the name of one directory, but you don't want that in the name of directory. You want it in the name of a image.img. Why? Because at last you have to load your image into the target board. You can't load each and every file. So you make it as an image and you can load. So for doing that, we are using mkimage. And what is all these things is, don't worry about all these things at this point. These are all the addresses, if no need to mention also. So you will get JUD image. JUD image is the final output of the kernel. So what I am doing here, it will be created in, so if I am using ARM architecture, it will be created in boot directory. So I am copying that image to my own name, GL11KR. So I am giving my own name. So now that my kernel and uboot is ready, what is the next step is, I want to format my SD card and load this images, right? Now what, okay, rootfs is pending. Okay, how to build this rootfs? We need to have two partitions, right? Boot partition and root partition. In boot partition, you are writing your uboot and kernel. In root partition, so this is the root file system architecture. So even if you see in your PC also, you find all these files. cd/enter, if you see, bin file, dev file, home. These are all the directories which contains corresponding files which are required for your operating system. Here also we are building operating system, right? So we need to have some preloaded files present, like how your Linux machine behaves, the same it has to behave in the target board also, right? So for doing that, you are building the root file system. You can see what is the bin directory contains basic programs, boot directory contains kernel image, dev directory contains dev files, just information about all the directories of a root file system. Now how to make root file system. So first we are making a rootfs. This is a workspace we are creating, and this rootfs you are making this all directories, dev, proc, sys, bin, whatever directories you are seeing in slash directory, you are making all of them. And now populate it with bin, sbin, target mission using. So now this BusyBox is one kind of tool. It is when you compile build root, like what you see, right? Build root. So by using the build root, you can generate a BusyBox. BusyBox is it is an integration of all the tools. What are the tools? What are the binaries you are present in this every directory? All the binaries are present in the BusyBox. So what you can do, directly cross compile this BusyBox for your target architecture. Then you can get all these binaries which are compatible for your target architecture. BusyBox is an alternative solution extremely common on embedded system. Rewrite many useful Unix command utilities. See, you are giving ls, cd, all these commands, but you have to build the same commands in the target board also. How do I do that is by using BusyBox. BusyBox is it is what you can find in the busybox.tar.gj2. If you give, you will get the source code. I am searching for the source code for BusyBox. So after taking the latest version, I have to cross compile again. Whatever I need for my target board, one thing I have to do is download the source code from the internet and cross compile it for my target board. That's all you have to do. So this BusyBox contains all the files which are required for the root file system. After compiling them, then you are ready with your root file system. Again, you have to make the root file system in the form of image. So how to configure BusyBox also? It is given here. You can see http busybox.net. Download the file, extract it, make menu config, and then cross compile it. Make cross compile equal to make install. That's all. So you will get all the binaries which are related to your operating system. So just follow the steps that are there in this file. So now create a profile. So it is not mandatory. All these things are not mandatory. Up to the which is mandatory is you have to cross compile the BusyBox and you will get all the binaries and all the directories which are required for your OS. I mean your operating system target board. Okay, now you are ready with your files also. Now you have to create in the form of image, right? You are just populating each and every directory here by using this command. Just follow this command. Okay, now this root file system we have to see how to generate an image with root file system. As you can see here, there is an SDK here. As I told you, whenever somebody is selling board for you, they will give SDK also. What this SDK contains is how to install a toolchain, how to install your toolchain, what is some basic application I can write on my device, how to start writing application on the device. These are all the contents of this SDK. Usually a board, when you are the developer, right? The developer should give all this information about the application developer. You are an embedded developer, you are working on the board side, so then you have to give this information to the application developer. So then he will install all these things and then he can write his own application. Next, tool chain. This is the tool chain for my rootfs also you can find here. This is the rootfs tar file. So you have to no need of writing as an image for rootfs. You can just zip it. Tar is nothing but a zip. It's one kind of archive. So I am zipping all these binaries and libraries which I got from BusyBox into a tar file, and I have to load these images into the SD card. This is my final step. Let me do that with how to format the SD card. We'll see now. SD card partitioning. Fdisk is a command in Linux which is used for partitioning any kind of storage device. So you have to first give fdisk-l So in the first document, you have seen what are the partitions you need to make for your booting in the booting.pdf. What is the first thing you have seen here? Procedure. Connect the SD card to the host system and create two partitions, one for boot and another for root. And create two partitions, with one with FAT32 file system and another with ext3 file system. So your boot partition should be FAT32 and root partition should be ext3. This is what the procedure they given, right? Now according to that, you are partitioning your SD card by using Linux command fdisk, which is that one, rootfs SD card. Yeah. Now first, connect the SD card to the host PC by USB or any type of connector. Give this command fdisk-l. Look for the dev file size of the SD card and partitions on it. Dev file is needed to perform, so it's just about explanation about what it will do. And now create the partitions by using n. So after giving fdisk-l, let me give this command. I don't have anything now to partition. If you give fdisk-l, you will get this one. So if any device is mounted, then it will stop in the partition number 1, and from there you have to give n command. To create a new partition, you have to press n. What is the partition size is up to you. For example, you have a 4 GB memory card with you. You can create 2 GB for boot partition and 2 GB for root partition. How much size that is up to you. For size, you have to enter in the multiples of 256 MB. So these are all the steps. So you can, after doing that, you have to convert into file system. How do I convert the first partition to FAT32 file system is mkfs.vfat. So this is a command to convert your partition into one type of file system, vfat file system. And as I told in the document, the second partition should be ext3 file system, that is for root partition. So now we have created two partitions. One is of type vfat and another is of type ext3. Got that? And you are listing all. After doing this, so after inserting a pen drive, you will be getting, SD card, you will be getting a node. Dynamically create a node. So if I insert pen drive, okay, let me tell you. So now I have a pen drive with me. I want to partition this. So now in the /dev directory, if you see, there are no SD A1, B1, A6 or the dev files I have. There is no file with SDB. Now if I am inserting my pen drive now, I'm inserting now. Yeah, I have inserted now. It should be auto mounted and it should be shown here. So it is now showing here, and it is showing some files here. So now for this, if I go and check in /dev directory again, there is another file called SDB. Before, there is no SDB partition here. After SDA6, SG0 is there. So now a newly created node is created in /dev directory, right? So this is called dynamically created file, node file, when I insert any hardware device. So this is for USB kind of devices, and if any other devices, the name will be different. Okay. Now I got this STB. So what I have to do now, I have to partition this pen drive by using fdisk-l command and fdisk/dev. What is the node I got? SDB. I have to give this. Now it is asking for create a new partition. So what is the primary partition extended? So it will, according to the document, you have to follow. I don't want to change my pen drive format now. So this is how we have to create partition for your pen drive. And then your images are now ready, right? Your eboot.bin file is ready, and your kernel image is ready, and root file system also ready. So you have to copy your eboot.bin file and kernel.img file in the boot partition, and then root partition you have to copy the root file system. It is just a zip file of all the contents of the BC box, all the directories of your operating system. Now what you have to do, you have to give booting, you have to follow the remaining booting procedure. What is the remaining booting procedure is, load, they have commands, how to load the images. You have the commands here. So this is the commands. You have to stop the booting procedure in the U-boot prompt and then set the environment variables and give the command. So now your U-boot is being loaded. You have to load the kernel. So by using this command, load MMC. Load MMC and give the RAM address and give the name of the kernel image, Z image. You can write your own name and DTB files. DTB files are newly added in the newer versions of kernels. Before that, why does DTB means? Before that, what happened is everything is present in the kernel source. So if any hardware got changed, what we have to do is we have to go and change in the kernel source and recompile the kernel one more time. Any hardware got changed means recompilation of kernel will take almost 1 hour to 45 minutes and even more than that. So for avoiding this repeated recompilation of kernel which takes time, they have introduced a new concept called device tree. What is this device tree means? Hardware information, everything is stored in one file that is called DTB file. So if anything hardware is changed, only if you have to go and change that file, that is not part of your kernel image. You have to compile that image separately. So it will take all the information from this file and your kernel will run. So then now it has compatibility, right? If hardware got changed also, no need to recompile the kernel, just change this file and compile only this file. And your latest kernel will take the whatever there in the latest file. Okay, this is the use of device tree. Okay, so now after loading the kernel, you have to load the root file system. That is all how you have to follow this document. How many ways you can load the image to the target board is, first thing is you can do download with NFS, I mean network file system. The image will be present somewhere in the network. You have to download that image and you can load it. That is one approach. And you can download the image and you can load the image via SD card, like how the format the SD card, load the your custom images and load onto the target board. That is second procedure. And third procedure is, there is another protocol called TFTP. You can see this TFTP, booting the kernel with network via TFTP. So there is procedure given here for TFTP. Usually we will go with loading the image with SD card or any kind of storage device eMMC. There are possibilities you can download the image via TFTP to your board. That is also procedure. If you want, you can refer in this document. Is this clear? So can anyone explain me what is the steps I have to follow if I have a new board with me? Can anyone tell me? What are the prerequisites I should have? Are you following? Any doubts here? This is totally a dry topic for you, I can understand. That's why I'm asking plenty times. If you are not okay, I can tell you one more time. See, this is theoretically, it will be dry only. If you do in practice, then it will be more and more interesting. That's why I'm asking you to buy this board and do these changes. And if you download your customized images and run in the board, that is like a project for you. Any doubts here? Anybody interested to do it in practical? I can help you for you if you're stuck anywhere. Hello, am I audible? Sir, I don't understand if you don't respond. Hello.